project. A lot of my work involves working with universities in research projects. Some of them that I've done in the past. I've worked a lot with universities, and actually the talking about McLuhan is relevant because I was a head researcher at the McLuhan program in culture and technology at the University of Toronto, running a virtual reality artist access program back in the 1990s. And part of that research showed that kids who are sick have a really hard time going back to school, is that they become disconnected with their social and learning environments. And part of the video conferencing artworks I was doing became this product, which is Pebbles, the video conferencing robot, which is a collaboration between Ryerson University, myself and my company Telbotics, and the University of Toronto. And actually you're going to be able to see another one of these. This is, oh, I hate Windows machines, sorry. Okay, yeah. This is the web chair, and it's my latest and greatest invention. And we just struck a deal with KPN where they're going to put 30 of these in to help, again, sick kids link from their schools back to their learning environments. And it's got a Mac Mini inside and a screen that rotates, and it links on Skype video back to the kids who are sick. This is the group of students I worked with at HKU, the Utrecht School of the Arts, in industrial design and robotics. And we took this idea that Ryerson had been working on. And the idea is that when people are hard of hearing, are deaf, and they see a video, you know, in an Alfred Hitchcock film, you know, when the murderer is coming up behind the person and the music is kind of going doo, doo, doo. You know, we have this emotional impact because we can hear, we understand that. The person who's hard of hearing watching this, they're seeing a thing on the bottom of the screen saying very scary music, you know, and they're going, oh great, you know, scary, yeah. So you'll see what we've decided is, you know, McLuhan saw video as a very cold medium and film as very hot. And the reason he said that was that in film, you're getting an incredible amount of information. Video scans, it's very low resolution. So your brain has to work to actually build up an image. Whereas film is a very rich medium. It's lots of visual information. So what we're trying to do is turn video from a cold to a hot medium. And how do we do that? Well, let's go back to this stool here. Oh, sorry. Wrong one. You know, the stool itself, or the chair, and actually the real name for this thing is the Assisted Sensory Information Display. And I don't know if it was a little bit of a joke they had, so it's the ACID project, which, you know, developed in the Netherlands. Okay, well. So what we decided to do was combine a whole series of senses. So when there's a scary moment in a film, you get cold air at the back of your neck. When you see the monsters come in the movie, your whole chair is on a motion platform. When the fire scene comes up, you smell the smoke and you feel the heat. We're also including colored lights so that the screen will light up into different colors. When it's cold, it'll be very blue. When it's hot, it'll be very red. And you also have speakers all over your body, so you're feeling the sound from this device. And you know, you have to experience it to understand it. And so some of you will get a chance to do that. And I just want to show you something here that, you know, I've been making crazy technology for most of my life, from virtual reality to telepresence to robots to God knows what. And when I saw this video, it actually really freaked me out. And it takes a lot to freak me out. And I think this says it all, actually. So we'll try playing this.
glance, Roger Bain looks like an independent guy who loves his power tools. And he is. But here's what he's actually seen since he was a young man.
Camera that you can put around.
But part of his world is slowly coming back into focus through experimental technology called Brainport. One day it could actually help blind people see, in a sense, using their tongues. Yes, their tongues. It swaps tiny cameras for eyes and transforms the images into electrical impulses that are felt on the tongue.
It's as if it's drawing on the tongue the still image, and so if you capture the images fast enough, paint them fast enough, it's like a video display. Instead of being on a screen, now it's on your tongue.
You know, when you're a kid, I don't know if you did or not, but when you're kids would draw on your back and you try to guess what it is.
In normal vision, the eyes send signals to the middle of the brain. From there, the signals are sent directly to the visual cortex at the back of the brain. Not so for the blind. The Brainport retrains the way the brain processes information by first stimulating the tongue with an array of tiny electrodes. The nerves in the tongue send signals through a different pathway to the brainstem and the area that deals with touch. Eventually, the blind person learns to interpret touch as sight in the visual cortex. Sounds impossible? Well, watch how Roger walks through the Brainport office without any guidance. He can navigate this obstacle course, picking out specific shapes.
Excellent.
The camera sees this image, Roger feels it on his tongue, and that's how he can even spot the logo on a football jersey.
Very good.
Other blind volunteers recognize numbers.
9. It's like learning a language. At first, you might need to spend a lot of time thinking about what the translation is. I may feel stimulation in the right front part of my tongue. What does that mean? But very rapidly, like learning a language, you might learn a few quick vocabulary, and eventually you become so fluent that you don't need to think about it anymore.
Blindfolded, I try it myself.
Gonna tighten it.
After a humbling first attempt,
I want to say it's diagonal.
Okay. And this one is vertical.
I managed to understand some of the Brainport language.
I want to say it goes this way.
You are correct.
Okay.
The technology is improving. Today, a car looks like this to a Brainport user. A few months from now, they hope it will look like this. And in a year and a half, more like this. For the blind, they're a glimpse at more freedom.
This develops where the next generation can really get benefits from it. Even if I don't get the greatest out of it, I'm still can determine if I can see their eyes and maybe even see a smile or a grin, you know, that kind of stuff. It can be cool.
And for the rest of us, it's a miraculous look at how our brains can be trained to rewire themselves. Daniel Seberg, CBS News, Madison, Wisconsin.
Now Carmen's is going to set up the display so we can have a little test and to see what it's like. But I found that video specifically interesting because, I mean, who would have ever thought that you could see through your tongue? I mean, that to me is such a bizarre concept. And it goes back to a friend of mine who became blind. And she developed a very large part of her eyeball which cracked. And she developed a big, huge black spot on her eye. So she couldn't see this whole area here. It was just impossible. And yet, she didn't notice it. When she looked around, she saw exactly what you see. Because her brain would fill in what it thought should be there. And it wasn't until you took a piece of paper and wrote a number on it and hid it from her and then put it in that spot that she could see that you were holding up a piece of paper. She could see you, and even though she couldn't really see you, her brain filled that in, but she couldn't tell what the number was. And that to me is such an amazing thing. It shows us that we're only seeing a tiny portion of what is out there, of what we could see. Is that our brains fill in stuff that we haven't got a clue what it's filling in. So I don't know if Carmen, you tell us when you're ready over there. We don't want to stress you out too much. 2 minutes, okay. Has anyone got any questions about the project or the emotion chair? Does anyone want to try it? Any volunteers? Yeah? Okay. It's only €5, don't worry. It goes for a good cause. Just joking, just joking. Okay. Yeah, and I mean, I got to apologize because in some ways, because some of my students who already have their mark and promised they would have the video for this finished, well, I don't see them here tonight. So we're using other material, more commercial stuff that we've pulled off the net just to demonstrate it. And the emotion chair, you'll find that the one sense that we're really having a hard time, and I really want to see the thing on smell tonight, is smell. It's such a difficult thing to generate a various ranges of smells. And once you do include numerous smells, it's sort of like, it becomes like a smog, and you don't smell anything very quickly. So we tried using fans to take the smell out of the environment, and we use this thing called a scent dome, but basically it just smelled like perfume to me. So, you know, I think ultimately from a practical point of view, we will not include the smell ultimately in the final device, because there's just no practical way. I mean, if you want to create sound, that's easy. If you want to create color, that's easy. Vibration, air, these things are incredibly simple to do with the technology we have. And yet smell is probably the most primitive and most basic kind of sensory input, but it's the most difficult to control from a media perspective. And maybe ultimately there's some way to stimulate that, just as they did with the tongue, you know, on the brain. Maybe if I have a speaker on my, you know, a certain part of my body that I'll smell things or something. I mean, who knows where it's all going to go. But I think are we ready over there yet? Okay. I guess we have to find a willing victim. Any volunteers? Okay, now what we're going to do is, though, is we're going to cut the person off from the sound inputs, because you're supposed to be deaf. So we're going to give you earplugs, and I believe they're right out of the box. So, and we're also going to play white noise through a pair of headsets. So when you're seeing the film, you're going to have earplugs in, and you're going to hear white noise. So basically, you're going to be cut off from your sound environment. Okay, here you go. Whoa, watch out. Now these speakers, you put your hands on there, that's right. So we found that this part of your arm is very sensitive to sound. Yeah, that'd be better. Here, I'll hang it up for you. Or I guess you can't hear me. Okay. Okay. So, are we ready to?
1 minute.
1 minute.
1 minute from takeoff.
Okay. You're not hearing any white noise?
Oh. Can you play it on iTunes?
As you can see, there's tons of wires, and like I say, this device will be shipped back tomorrow, and it will be used for a series of experiments over the next couple of years with people who are deaf to gain an insight into how they can feel. So we will eventually have colored lights around here that we can change. We've got the lights in here, but we haven't got the controller. You can see these are just changing randomly right now, but they will be able to be computer controlled back in Toronto. This is a very complex device. Well, it's a blow dryer, okay, but it does very easily simulate heat. Now these are we call these Medusa's a hairdo kind of, and believe it or not, this is a machine tool for machining equipment where they bring in cutting fluid into high-speed devices to cool the metal that they're machining. We've kind of used it in a different kind of way. So this one will be for the very scary back of the neck sensation. And the reason we designed it like this is we wanted to make it so the person himself or herself could put the device where they wanted it. Because it is kind of shocking, as you'll find, that that people have their own specific place that they like to to have air blown at different parts of their body. I kind of like it myself. It gives it a kind of a David Cronenberg, another great Canadian, by the way, but anyway. Okay, I think we're rolling. And the first clip we're using is, well, okay, it's cheesy, I know, but you got to come over here, is Jurassic Park. Okay, well.
Ready?
So, I don't know, you're going to have to come over this side to see it. Either that or we could have someone with a video camera look at the screen and then project it up there, but. How's our test subject doing? You still alive?
Yeah, it's okay.
Tell us what it was like.
All these trouble for such a bad movie. What happens if you look at a really good movie? I mean,
well, that's what that's what we're looking at. I mean, you know, we really want to work with filmmakers to see what happens when how you can combine these kinds of inputs into really incredible artistic experiences.
the arms are interesting. I felt.
Yeah, you really do get you really do feel part of the movie through the sound in the arms. That's what I felt. You really, even though you can't hear it, you get a sense of it.
Yeah, and it scares the shit out of you if you have suddenly have a thing in your neck.
And the very last demo tonight, we'll do the smell demo, but it's from Backdraft, so you might think the place is burning down, but it's not.
Are there more questions for Carmen and Graham, or even Arjen?
You put all the effects in with this one movie, right? There's no translation of through software of film.
Well, no, not automatic. I mean, what we've done is we have a max patch, so that if it's on the computer, we can control different things through the computer to do it at different times. Right now, we're just doing it manually. But back in Toronto, they'll be able to run a max patch program that just runs the whole thing automatically.
But what then does it translate? The sound into movement, or?
No, we're trying to find out what the experiment is. What works. I mean, you know, the back of your head definitely is weird, scary shit. You know, you do pick up stuff on your arms. The sound of the movie somehow translates, even though you can't hear it. So the idea is to experiment to see it's an experiment, so we don't know what the results are going to be yet. Okay. Well, we'll come back to you in a year and tell you.
Okay, thanks. Maybe it's best if